it's red now. Hey, I think I got it.
Hey, yeah. I can see them.
You can see all of them, right?
I see 3.
Well, okay. All you get is 3. What happened was it went on pause again because I changed it. And what I did, it turned red over here on the camera. And when I clicked it, it said film again. So that's what it is. So now we take it off and pause. Put it on pause. It'll go to pause and it'll turn red.
Okay, good.
We made it.
I printed my sign-in sheets. Now I can't find them anywhere. Oh, today is Monday. Ah, there they are. Okay. It's a whole board. Okay, so now if I share my screen.
Mine's just colorful.
Well, I got my camera was showing, now it's not. What did I do last time to get my camera to start? Ah, there it is. Okay, Marjorie, can y'all see my notes?
No.
No? Okay. Because we can see them here. I didn't know if y'all could or not. Okay. Now, how are we doing on the notes? All I did was print this from the textbook because I found out I didn't have any notes for it. So if I can get this. So what we're going to look at today is it's starting chapter 2, it's 2.1. It's the Cartesian coordinate system. So we're going to start graphing, writing equations of lines and graphing lines and all these neat little things that we're going to do. Today we're going to look at the x and y intercepts and the distance formula and the midpoint formula. I'm pretty sure most of us are familiar with plotting points. So anyway, still planning on testing on Wednesday. I won't be on campus on Wednesday, so the test will be online. My husband has to have surgery Wednesday morning, so it was supposed to have been last Thursday. Anyway, they didn't do it, so it's going to go Wednesday. So I'm going to have to stay home and take care of him. He's a big baby when it comes to surgery or pain of any kind. So it's not a big deal, but it's still going to hurt. He won't be able to sit down for a while.
So you said test online next Wednesday.
Right.
Okay.
And I'll open it sometime during the day Wednesday and give you 2, 3, 4 days to work it. Something like that, maybe a whole week, maybe from Wednesday to Monday, something like that. Monday, I've got another doctor's appointment, a follow-up on my leg, on my ankle, hoping to get either off the crutches or out of the boot or both, which would be nice. So I won't be on campus Monday either. So that will leave us with doing some kind of activity online on Monday. Okay. All right, so let's go back to our quadrants. And so the Cartesian coordinate system is a grid system having perpendicular axis, and the horizontal is x, the vertical is always y. The center is 0, 0, because basically what we have is we have two number lines, okay? So 0, 0 is our center. If we're looking at the horizontal, everything to the right is our positive x. Everything to the left is our negative x. And then x, of course, positive x goes to positive infinity. The negative x goes to negative infinity. Unless you're looking at just a specific part of the grid. I'm going to give you an activity to do later between now and next Wednesday that you're not going to go on to infinity. It's just a specific part of the grid. So many points on the grid that we're looking at. And I'll show you later. Going up is positive infinity. That's our positive y-axis. Going down is our negative y. Goes to negative infinity. So the graphs can go on and on forever. Now we have quadrants. Everything in quadrant 1. Of course, our points are always written as x and y. Everything in quadrant 1 is positive, okay? So between the two x and y axes, that's our positive x and our positive y. Quadrant 2, our x is negative, but our y is positive because we're between the horizontal and the vertical here. And just everything over here. Quadrant 3, our x is negative and our y is negative because we're in the bottom third. And then we go to quadrant 4, our x is positive and our y is negative. Because again, we're in the bottom, but we're on the right side of the y-axis. So our ordered pairs will always have a positive x and a negative y in quadrant 4. Or a negative x and a positive y in quadrant 2. The center is also called the origin. I always call it the center. And so this is what one would look like that's just going to 5. Okay. So if I wanted to graph a point, and I'm sure we've all done this at some point in our lives, but it tells me to graph 3, negative 1. So the 3 is my x, the negative 1 is my y. So I'm going to go over to 3 first, and then I'm going to follow that shaded gray line down to negative 1, where negative 1 and that 3 meet. That's my point. 3, negative 1. Okay, so it's where those lines intersect, is where my point is. If I wanted to graph 3 and positive 2, I'd go over to 3, and then I'd go up to where it intersects at 2. Okay, it's just kind of boring, right? Plotting lines. All right. I don't like some of this, looking at this, but it works. So it says that we're wanting to graph the equation of a line, or graph a line. Yes,
Can you make it bigger for us?
yes, I'll try. Is that better?
That's better.
Okay.
Y'all see what?
All right, so we want to graph the equation y equals 2x minus 1. And basically what we're doing, and some of you know this, is we're making an XY table. Y'all, depending on how far back it's been since you've had Algebra 1. And what you do is you choose points for x, and that's what they've done over here. They've chosen several points for x. They plugged it in for x into the equation, and then solved for x. And then they get the point. So in our XY table, we'd have like -3, -7. And I'll work one of these where I'm working it all out. But that's what they've done for all these points. They've taken 0, plugged it in for x, and they did 2 times 0 minus 1 and got -1. And then their point was 0 and -1. X is always the number you chose. Y is always dependent on the number you chose. So x is our independent variable because we choose what we want. It's not dependent on anything. It's just we kind of pluck them out of thin air. And then the y is our dependent variable because it's dependent, or depends on what was chosen for x. So if you hear about the independent and the dependent variables. X is always independent, y is always dependent. Because y always depends on what we chose for x. It also depends on our equation. So then in order to graph the line that goes with this equation, we're going to plot all these points, and that's what they did over here. They plotted all these points on the number line. That was the first one we had. So they started with -3, -7, and then the other one was 0 and -1. It only takes 2 points. They've graphed 6 or 7 here, but it only takes 2 points to graph a line. Okay, so we're going to look at this equation here, the y equals -x plus 2.
Can you break it down for us?
I just realized it wasn't there.
Okay.
Okay, and I'm going to do this on notebook paper. So y equals -x plus 2, and then I'm just going to choose probably about 3 numbers, okay? I choose a positive, a negative, and 99% of the time I'll choose 0, okay? Not always, but I always like to choose 0. And then I'll choose a negative number and a positive number. And the 2s are always my go-to numbers, okay? So then I'm going to put them in for x. So when I say that, okay, x equals -2, then I have a negative because x was negative. I'm putting -2 in for x plus 2.
Was it like a positive 2?
Because it's a negative times a negative becomes a positive 2 plus 2, so it's 4. So my first point is -2, 4. Then I'm going to do the same thing for 0. I've got a negative because x is negative. 0 goes in for the x plus 2. Well, a -0 is still 0, right? Because 0 is neither positive nor negative. So 0 plus 2 is 2. So I have a 0 and a 2. Okay. Yeah. And then I have, again, the negative. I'm putting the positive 2 in for x plus 2. A negative times a positive 2 gives me a -2 plus 2. Negative 2 plus 2 gives me 0. So I have a 0 here.
And then you would just plot them on the
Mhm.
graph.
Yeah. And I'm going to draw a very sloppy graph. And y'all can pretend that all these are equally drawn. Okay, so I'm going to draw negative 2. Okay, on X. So this is positive, this is negative over here. So I go to negative 2. And then I'm going to go up 4. So 1, 2, 3, 4. And where those two lines would intersect is where I draw my point. And I'm going to label it negative 2, 4. And then the next point is going to be at 0, 2. So I'm not going to go left or right because I'm at 0. And then I'm just going to go up 2, and that's where my next point goes. So that one's 0 and 2. And then I have 2 and 0. So I'm going to go to the right 2, but I don't go up or down because I'm at 0. And so this one is 2 and 0. And then I just play connect the dots. And there's my line. Yes, ma'am.
On the negative 2 plus 2, why is that 2 a negative?
Because the X was negative to begin with. When we go back up to the original X, it was a negative X.
Oh, okay. Got it.
Okay.
I have a question.
Uh-huh.
Do you mind if we change the increments on a graph?
Yeah, you can change them to whatever you need them to be.
Okay.
So automatically, if it's a negative X or negative whatever, everything to the left should be a negative, right?
Not, well, it depends on how it's written.
Yeah, I'm saying if it's in the same instance, like how you got it, negative X.
Uh-huh.
And it needs to be a negative 2, and negative 0 is 0, and a negative 2. So everything to the left side.
See, this is, I got 3 different problems written here, so.
Right.
Okay, let's do another one. Maybe I can clear up your, hopefully clear up your confusion.
Okay.
All right, let's look at y equals 1/2 x plus 2. Okay. Now, I do the XY tables, but if you want to, we can do the y or the x and then the equation, and then we can do the ordered pair. It's just a different form of the XY table. So I'm still going to use the same 3 numbers for x. Y'all can use whatever numbers you want to, okay? So now I have 1/2 x, so it's 1/2. I'm putting negative 2 in for x plus 2. Now, too, if you want to use a calculator and do the math on this, I'm okay with that. So 1/2 times negative 2 is negative 1. Negative 1 plus 2 is 1. I didn't leave enough room. So then my ordered pair is negative 2, positive 1. Then I'm going to put a 0 in here. So I've got 1/2 times 0 plus 2. 1/2 times 0 is 0. Plus 2 is 2. So then my ordered pair is 0 and 2. And then I've got 1/2 times a positive 2 plus 2. Well, 1/2 times 2 is 1. 1 plus 2 is 3. So now I have 2 and 3. So when I go over here and draw my XY table, or my graph, best looking graph I've drawn in forever. Okay. So I'm going to start with -2 and 1. So I'm going to go over to -2, go up to 1, and that's my first point. And then I'm going to do 0 and 2. So I go to 0, and I go up to 2. So that's 0 and 2. Then I go over to 2, and it's always on the x first, and then up to 3. And this time my graph goes this way. So you're just plotting points. You're using your equation, choosing your values for x, and then taking the values for x that you have and writing the equation of the line. Or not writing the equation of the line, drawing the equation from. Let me try that again. Drawing the line from the equation. Okay, so questions? Did that help, Tammy?
It's okay.
All right.
Last English.
All right, so now we're going to look at the x and the y intercepts. The x-intercept is where your line crosses your x-axis. And of course, your y-intercept is where your line crosses your y-axis. Okay. Then one thing we realize, or we need to realize, that when we're talking about the x and y intercepts, when my line is crossing my y-axis, so if I use this line, okay. So again, this is my x-axis, my y-axis, positive x-axis, sorry, y-axis, negative y-axis. This point right here would be my y-intercept. What's the value of my x when my point is sitting on my y-axis?
0.
0. So my x will always be 0, and my y is going to be whatever the y is. Okay?
Same thing with the x-axis.
Same thing with the x-axis, except what is the value? It's the value of y that's 0 this time, right? So my x is going to be whatever x is, and my value of y is 0. Okay? That's how you know you've got the intercepts. If you've got the x-intercept, y is 0. If you got y as 0, then you've got the x-intercept. If you got x as 0, then you've got the y-intercept. Alright, I've got to go and find something, so just bear with me. Yeah, question? Have y'all ever heard of Desmos?
Yeah.
Okay, so we're going to use Desmos graphing calculator. Why is that so good? Okay.
Miss Young,
Yes, ma'am.
there's something wrong with your voice.
Something wrong with my voice. So I need to turn. How do I turn my mic up?
You can hear it, it's just like muffling or something.
Like you're talking into a barrel.
How entirely possible. I'm talking behind this plastic thing. Does it help if I speak up?
I mean, we hear you clear now. I mean, you're clear now, but.
Okay. I wonder if it's picking up off my mic on my Ladybug instead of the other, on my document camera.
Did you just say Ladybug?
Yes.
Okay.
My document camera is called a Ladybug. That's the brand it is.
Oh. I was like, is it really a name or is this just what I'm hearing?
No, it's really a name. All right, I'm going to go to Desmos, but I've got to figure out how to share my Desmos screen. I guess I'm still sharing this. No, that one. Okay. All right, so here's Desmos. Can y'all see the graphing calculator?
Yes.
So it tells me that I need to put in this equation. So I'm going to put y equals negative 2/3 my variable x plus 4/3. Whoops. Okay, let's go here. Let's do this one, 4/3. One thing I like about Desmos is I can zoom the screen in, or I can zoom the screen out. Now my x intercept is pretty easy to find because it's right here on the line, right? 2 and 0, and that's what I like about Desmos again. I just click on it and it shows it. But my y-intercept, it doesn't really fall on anything. So I've got to click on it, and it's 0 and 1.3, which would be 1 1/3. Okay? So this one thing, and everybody has access to Desmos, so you have to do is type in the Desmos, DESMOS. Yeah, use your student email, it makes it easier. Just you can sign up, or sign up. That's what you need to do. There's a couple of activities we'll do eventually on Desmos. So, but it's real nice to have, real nice and handy to use. And I can change it from that one. I can add and do y equals 3x minus 1. How come it's not in there? Y equals 3x minus 1. And so again, yeah, and you just type on the screen, not type on the screen, but click on the screen and you can move it. Here's my y-intercept. There's my x-intercept. Okay. Makes it very easy to find them. If you don't want to do it algebraically. All right, so questions. All right. So one of the activities we're going to do is the using the distance formula. All right. And our distance formula is d equals the square root of x2 minus x1. So we're difference in our x's. You square that value plus the difference in our y's squared. So if I want to find the distance between 2 points on a graph, or this is part of our activity. If I want to find, if you're a plane and you're flying, or you want, they say the shortest distance between 2 points is a straight line. So if I want to find the distance from Corning to Walnut Ridge, the shortest distance, which would be like a plane would fly, then I find the coordinates for Corning and find the coordinates for Walnut Ridge, and then use the distance formula. I think I would probably choose something better than Corning and Walnut Ridge. I'd fudge a little bit. Because let's say this is Corning, and it goes all the way down to here. So 1, 2, 3, 4, 5, 6, 7, 8, 9. So my X is 9. And it goes to here. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. That's 15. I don't want to go back and count again. 16, 17, 18, 19, 20, 21, 22, 23, 24, 25. So it's 9 and 25. That's my ordered pair, or my coordinates for Corning. If I fudge a little bit and scoot it this way to get Walnut Ridge, then my ordered pair is going to be 1, because I'm just 1 over, and 15. So if I want to find the distance between those 2 points, I have 1 and 15, and 9 and 20. I'm going to use those ordered pairs to find out how far it is. So I'm going to find the difference in my x's. The first term is always x, second term is always y. So x2 would be 9, minus x1 is 1. I'm going to square it. y2 is 20, y1 is 15. And you always read the graph from left to right. That's the reason I'm using Walnut Ridge first. Because if I'm going from left to right, Walnut Ridge comes before Corning. And then I'm just going to do the math. 9 minus 1 is 8, and it's squared. It should be a minus. 20 minus 15 is 5 squared. 8 squared is 64, 5 squared is 25. 6, 7, 8. So it's the square root of 89. Here's my calculator. And then in your calculator, make sure you turn it on first. You can take the square root of 89, and you have to have it in the right mode, which is not math print, it's classic. So try that again. Second square root, 89, and it's 9.43. So it's 9.43 units. Because these aren't miles, trust me, Corning is not 9 miles from Walnut Ridge. On our graph, it does tell me that 1 unit equals 3 miles. So to find the miles, I'll take the 9.43. You can round it, if you wanted to 9.5. 9.5 times 3. It's 28.5 miles. And that's pretty close as the crow flies, or as the plane flies. It's 45 miles if you drive it by car. I drove it for 5 years.
Normally measure distance by hours. It takes you about an hour to get there.
Yeah. It depends on traffic in Pocahontas. I mean, I've gone through Pocahontas and it takes me 20 minutes to get from one end of town to the other.
Yeah, but no one says, it's about 20 miles. So.
Yeah, no, nobody says 20 miles. Now, how far is it from your house to Noble? About 20 minutes. And it's probably about 15 miles.
And we also use the different systems in the rest of the world and stuff.
Yeah.
We all use time and locations.
Yeah. I love it how, you know, some places you can go and they'll tell you, you go 5 miles up the road, then you make a right and go a half a mile. In Arkansas, go up the road to so-and-so's house, make a left, or so-and-so's farm. Around my house, it's so-and-so's farm. You know, at so-and-so's farm, make a left or make a right. Then go on up to probably about 3 or 4 fields and make another, you know, we use landmarks, you know, but it's usually so-and-so's house or so-and-so's farm or so-and-so's field. But there's a lot of times you can't. Up north, they will give you miles and distance. They don't give you landmarks. I'm like, no, give me landmarks. My grandfather had a 2nd grade education. Could not read, could not write. He could drive anywhere in the U.S., but he drove using landmarks. When somebody told him how to get there, they told him landmarks. And he could always follow landmarks. They didn't tell him what highway to take or anything. You take this highway at such and such landmark, you know. And when you get in Walnut Ridge, make sure you take, make sure you go all the way through before you get to the railroad tracks and turn right onto that highway.
You know, to be a taxi driver in London, you know, like black taxis, you have to know every street in London before you are a driver.
Yeah. Most police departments make you know every street in town. Our police department had to know every street. No, they used to anyway. But anyway, that's the distance formula, okay? Now, if, most of the time you'll be given the 2 points. Do I need to work another distance problem for anybody? Is that a no or a yes?
No.
Okay. And the next one is the midpoint. So the midpoint formula is an ordered pair, okay? It's the sum of my x-coordinates divided by 2, because I'm going halfway between the x's. That's my first coordinate. And then it's the sum of my y coordinates divided by 2, because I'm going halfway between the point. That's the reason I'm dividing by 2. So then I could go back to Walnut Ridge and Corning. If I wanted to know what is the halfway point, then I'm going to use the 1 and 15 again, and the 9 and 20. What's the ordered pair? Okay, so I'm going to do the sum of my x's. So 1 plus 9, divide that by 2. The sum of my y's, 15 plus 20, and divide it by 2. So 1 plus 9 is 10, divided by 2, that gives me 5. So my x is 5. 15 plus 20 is 35. Divided by 2, 35 is 14.5, I think.
You not just divide it by half, like the 28.5 by 2, and not do the fifth one? Or is that not right?
It won't give me the ordered pair. It would give me the miles. How far is the ordered pair? And this is 17.5. So 15 and 17.5 is my midpoint. So I'll go back over here to my map. Or 5, excuse me, that's 5. So I'll go over 5. 1, 2, 3, 4, 5. Up. There's 15, 16, 17. So 17 and a half would be about right there. That would be my midpoint from Corning to Walnut Ridge. And I'm out in the middle of the Black River Bottoms. Because all this area right in here between Walnut Ridge and Corning. And you know what? I didn't count right somewhere.
Yeah, kind of off.
It's off by a little bit. I may have miscounted.
I get the idea.
Yeah.
That
Okay.
does seem a little bit more than halfway. Right, could have been.
Well, halfway should be probably about right there. So. I probably miscounted something here, but you get the idea, I hope. And if I get, this is not a clean copy. I don't know where my clean copy went. But I'll give you a clean copy of this. Of course, we're going to do something different with it than this. So that's distance and midpoint. All right. And sometimes you may end up with problems where you know that one endpoint, and I'm going to use smaller numbers this time.
It gives you the midpoint and the
Yeah,
midpoint.
let's see. So -8 and 6 is an endpoint. And then I have a midpoint at -2 and -1. What's my other endpoint? Okay. So if I was to draw a line, and I'm going to call this A and this B, and the midpoint is M. I know that one midpoint is -8 and 6. My midpoint is -2 and 1. So I've got to find this other midpoint. Okay? We're going to use our midpoint formula where I have the sum of the x's divided by 2 and the sum of the y's divided by 2. And of course, this is x, this is y. This is x, this is y. Since I don't know what b is, it's going to be xb and yb. Okay? Because that's my endpoint b. And this is xm, ym. Because it's going to equal the midpoint for my x and the midpoint of my y. Okay? So this one's kind of done backwards, where before we were looking for the midpoints. This time I know the midpoints. So I know that -2 and 1 is my midpoint. And then the sum of my x's, well, one x is -8. The other x is my xb. It's divided by 2. Same thing with my y. My y is 6. My other y is yb, and it's divided by 2. So what we do is we take our x's and we set it equal to our x midpoint. So I'm going to have -2 equals the -8 plus xb over 2. That was not a good color to choose. And then I'm going to take my y and set it equal to my y coordinate, where I have 1 equals 6 plus yb over 2. Okay, so we're going to solve for xb and yb. We're going to solve for them separately.
Those these are twos under the
And here,
right underneath the line. Number up.
here,
Yeah.
they're 2s.
Okay.
My 2s and my z's. The way to tell my z's, it's got a line in the middle of the
Well, I
slide.
thought, but then I saw that the other one had the loop on the two, so I wasn't sure.
I make them both ways.
I didn't know.
The only thing I'm consistent with is my z. It's got the line in the middle.
Okay.
All right, so I want to solve for x first. So my 2 on the bottom, I got to get rid of it. So since I'm dividing by 2, I'm going to multiply this side by 2. Whatever I do on the right, I have to do on the left. Okay? So this 2 cancels this 2 because one's in the denominator and one's in the numerator. And I end up with negative 4 equals negative 8 plus xb. And then I'm going to add 8 to both sides. So 4 is going to equal my xb, or my x endpoint. Okay, so it's just, once you get rid of that 2, well, even with that 2, but once you put them together, you've got just a simple algebraic equation. All right, I'm going to do the same thing with the y's. Since I've got a 2 in the denominator, I'm going to multiply both sides by 2. So I end up with 2 equals, these 2's cancel, 6 plus my yb. So I'm going to subtract 6 from both sides. So yb equals 2 minus 6 is negative 4. So then,
explain that first up again.
the 2, multiplying by 2,
Yeah, because you said that it cancels.
it cancels. It's, when I multiply by 2, same thing as multiplying by 2 over 1. In multiplication, if you've got a 2 in the denominator and a 2 in the numerator, they cancel, as long as you're going top to bottom. So that's the reason I can cancel this. As long as I multiply over on this side, you know, what I do to one side, I got to do the other. You know, keep those scales even. I can do that. If I needed to divide by something, I could do that too.
And it just so happened to cancel too?
Yeah. Well, it cancels. You know, I did that so it would cancel. Since this was 2, I multiplied it by 2. If this had been 8, I would have multiplied it by 8 because I want to get rid of that denominator.
Okay.
Okay. So these 2 numbers will always cancel because you're always going to multiply by 2. So then my end point for B is 4 and negative 4. So if you're given an endpoint and a midpoint, then you're looking for that other endpoint. You're going to set it equal to your midpoint. Okay, are we good? Questions?
Can you go back up to the top for a second?
Negative 4.
Yeah, she just, I set it equal to 1. So like,
So your midpoint will always be on the left side?
Not always.
So how
Just-
do you know?
Negative 8 plus.
It just depends on what my endpoints are.
you multiply.
See, if I set this up on kind of a graph, my center and my underline's over here, then negative 8 is always to the left. And then the midpoint is negative 2, so it's going to be closer to 0. Okay?
So if it was flip-flopped, it would be the 8, negative 8 and 6 on the outside?
Could be. Let me give you another one. Do y'all need this anymore, or can I do another one?
You can do another one.
Okay. Let's see. Let's do negative 1, 4. Oh, negative 1, negative 4. And 5, negative 4. And I always, because I don't ever draw my endpoints or my, you know, I don't ever draw them to scale. But I look at my x's. So, well, yeah, let's make this one an endpoint. This one's my midpoint. So here's my line. All right, so my midpoint is negative 1 and negative 4. Okay, so my midpoint is 5, or my endpoint is 5. Well, 5's going to be to the right of my midpoint, right? And that makes my other endpoint A. So see how I set that up? And I do the line just because I'm a visual person and I need to be able to see it. But when I use my formula, it's my x midpoint, y midpoint is going to equal the sum of my x's divided by 2, and then the sum of my y's divided by 2. So with my midpoint being -1, -4, and then the sum of my x's, well, x1 is a, so xa plus 5 over 2, and then ya plus -4 over 2. Then I'm going to put my x's together, my x for my midpoint, so -1 equals xa plus 5 over 2. And then I'm going to put my y's together. So -4 equals ya plus -4 over 2.
What are those arrows doing? I'm sorry, I'll drop something.
That's okay.
What
What?
was the arrows doing?
This tells me that I'm just taking my x and putting it equal to x. And then my y goes equal to y. Because this one's x and this one's y. So then I'm going to multiply both sides by 2. Same thing as multiplying it by 2 over 1, so that my 2's cancel. And I have xa plus 5. 2 times -1 gives me -2. Then I'm going to subtract 5. So xa equals -7. Then I'm going to do the same thing with y. Multiply both sides by 2. So the 2's cancel. 2 times -4 gives me -8 equals ya plus -4. Now, even though I'm adding a -4. So I'm just going to add a +4 to it. I'm going to add a +4 over here. So -4 plus 4 cancels. -8 and 4 is -4, and that's my ya. So then I have -7 and -4 is my endpoint A. Okay. It's easier the second time you see it.
Yeah, I get it now.
Okay. And one thing you can always go back and do to see if it makes sense, I said my endpoint over here was -7, -4. From -1 to 5 is how many places? If I move from -1 to 0 to 1 to 2 to 3 to 4 to 5, it's 6 places, right? From -1 to 7, is it also 6 places? Yeah. So as long as there's 6 spaces difference, then chances are my -7, -4 is correct. The only, well, I could look like this too. From -4 to -4 is 8 places, right? And -4 to -4 is 8 places. Well, actually, they're all 3 -4 because it's a horizontal line. Just dawned on me. But anyway, you get the idea. You get the point. Okay. All right. Now, what we're going to do on our earthquake project, and this came out of a textbook, and I thought I had 2 of these. But what you're doing is, at the bottom of it, you have to excuse my purple up there, is it says, suppose your receiving stations are located at Newport, Paragould, and Wynn. I honestly don't know where the receiving stations are for the earthquakes, or how they, I know we've got several along, I know Memphis has one, but I don't know where they're really at, so this is all made up. The distance from the earthquake epicenter, which is the center of the earthquake, to Newport is 46.5 miles, so we're going to go up here to Newport. So from wherever the earthquake is to Newport is 46.5 miles. So you're going to have to convert your miles, your miles to units to get the radius of your circle, because you're going to have circles. So you're going to convert miles to units. And that's just taking your miles, dividing them by the number of miles per unit. Okay? So you're dividing them by 3. And this will give you the radius of your circle. So say it was, and I have no clue, say it was 7 units. So I go out from Newport, 7 spots, 1, 2, 3, 4, 5, 6, 7. And then I find something, you can go to Walmart usually and get those little things you draw circles with.
Compass.
Thank you, yes, compass. I didn't know this, so I was really hunting one up, but if you want a really good compass, you can go to Home Depot and they actually sell compasses. So I'm sure Lowe's does too. Office Depot, you might be able to get them, but you're going to draw a circle, okay? So whatever this equals to your radius, you're going to draw a circle with the center at Newport. The same thing for Paragould. Here's Paragould, your center at Paragould, you're going to draw a radius, or you're going to find your radius and you're going to draw the circle. Now you can't see what I'm doing. Where's Paragould? So Newport, where did I lost Paragould? Paragould, and then Wynn was the other one, okay? So you're going to find your radius, find the number of units, draw your circles. Wherever your 3 circles intersect is where the earthquake is. So if you draw these 3 circles and say they intersect like right here, just south of Jonesboro, then you're going to find the coordinates for wherever they intersect. And that's what I'm looking for. Okay, what's the intersection? Where is the epicenter located? All right, did it happen in Jonesboro? Did it happen over toward Osceola? Did it happen more closer to Paragould? So you're going to have to, all these miles that's down below this is given from, the distance from the epicenter to the station.
And what we're talking about with the circles.
You're gonna have to draw the circles. Like, when your radius, like back there in Newport. So Newport, your radius is here. When you line up, it's supposed to see. Okay. You're gonna line up the center of your compass here, and then you're gonna draw a great big circle, whatever your radius is. And then you do that.
Earthquake was?
That's the receiving station. Mm-hmm. But wherever all 3 circles intersect, it's the epicenter of the earthquake, where it actually happened.
So we have to use all 3 locations.
Mm-hmm.
And we pinpoint where the center of it is.
Right. And I don't know how many years ago, this is actually how they determined where the epicenter was. Back before we had the computers and things.
I was just looking, Miss Young.
Yes, ma'am.
Where we get this sheet from? I don't see it.
Yeah, I'm going to post it on Canvas as soon as I get back over to my office.
But how are we gonna print it off?
You can hang around for about 10 minutes. Let me get back to my office.
Sure.
All right, it's not going to be due till next Wednesday.
Oh, okay. Well, that's okay.
You'll have time to print it.
Okay.
Okay.
Huh?
So if you got, if you can, it won't be due for at least a week, maybe longer, if y'all have questions. So you'll have time to print.
Okay.
Okay. All right. So any other questions?
Yeah, how are we gonna upload our answers?
Do what?
Is there gonna be like an assignment where we upload our answers?
There's going to be an assignment where you'll upload the work and upload the answers.
Okay.
and upload this sheet that's got the graphs on it, where you showed all your work to find the, what are you finding? The distance or the length, the units, and then you'll find your coordinates. This is more about finding the ordered pairs than anything else, and being able to read the map. And being able to read a map is a key skill in this world. You know.
How will we, if we turn it off, do we need to just scan it into Canvas or just turn it in here since we're in your class? Or,
Well, it works better if you turn it into Canvas, because,
Then you said you'll be gone next month?
yeah, I'm gonna be gone next, no, not next, no,
Wednesday.
this Wednesday I'll be gone. Monday I'll be gone. Yeah, Wednesday, Monday, then I'll be back the next Wednesday.
Okay, let me mark out the next one.
Yeah. I don't know what the next Wednesday is.
October, I think.
Is it October? No, it's actually September 30th.
Wow, I was close.
You were close.
I was October 4th, so I was like,
I'm ready for the fall.
My nephew's 28th birthday. Yeah. Makes me feel old. I had a niece turn 17 this week. Now I've got a nephew turning 28 next week, or 29. I don't know. It's old. Makes me feel old. Close enough. Makes me feel old. All right. Then I'll also have some kind of assignment on Canvas to do something. I have no clue what it'll be. But
Something easy, because I have 100 in here and
I've got to put that. I really need to put that one assignment. I'll think of the words in a minute. My daughter says, "Mom, use your words." Or I have you tell how to factor something. Something simple. Either using the AC method or the trial and error method. Just put it in words, not really, well, you'll have to factor it to some degree.
define it.
Not just, yeah, how you find it, what steps. I'm going to, take, if it doesn't have a leading coefficient, if it's just x squared and something, then I'm going to take, the factors of the last term that add to be the middle term.
I think this is the longest I've ever had 100 in a math class
Right.
before.
Yeah, but how many grades have I taken? Okay.
I'm so bad. I just want my golfer now. I don't know right now because you don't have that much work. Because in my, actually my tutoring class, I had a B, and that's my lowest grade. And I was like, that's not tutoring class. I don't know why that's my lowest
Who do
grade.
you have for the tutoring?
Miss,
Miss Wilson?
yeah.
Yeah, because you do stuff in there.
She's, I was just like, I didn't know what was going on.
Like the class I'm wanting to major in, it's my lowest grade right now. We got a new major, so it's kind of.
All right. Well, I will see you all a week from Wednesday, so have a good break from me.
Everything's like that. But then, yeah.
Yeah. And I will have the test